Okay, I'll remind you again that we're taping. So everybody needs to keep it, yeah, because it really does interfere with the people that are using this. Okay? Okay, what we're going to talk about today is interpreting the lines of best fit. You are going to need your Unit 4 Worksheet 8 notes, since I have set up on here in the projector. And you're going to have to just kind of follow along. We're going to be bouncing back and forth a lot. And guys, this is a lesson that you can't just go, oh, you do this every time. No, you've got to engage your brain and think about what's happening. Okay? We've talked about slope and y-intercept interpretation now several different times. So you ought to be starting to get a feel for that. We've also talked about independent and dependent variables in Algebra 1. Does anybody remember what an independent variable is? It stands by itself, and it's what affects the dependent variable, doesn't it? Okay? In x and y terms, x is your independent, y is your dependent. You put a number in for x, it kicks out a number for y, doesn't it? It's your input and your output. So, remember in Cognitive Tutor, I always tell you, oh, on your table you always want your input on your left, and then always your x value. Agreed? And then you want your output on your right, which is usually your y value on your graph. Agreed? Okay. So, we need to look at problem number, and it says 1, but guys, it's actually number 4 on your notes from Unit 4 Worksheet 8. Let me scroll down here. So, this was the population problem. You guys remember the population problem? Okay. Which one's independent? Is it year or population? Independent. It's year. And so, up here, for question number 1, it says, for number 1, state the independent and dependent variable. Well, the independent was the year. Now, don't get lazy. Didn't we make a 0 year when we did that? Which year was our 0 year? 1975. So it's our independent is our year from, or years from 1965. And we're finished. Any questions about that? All right. Now I'm going to scroll on down. We're going to look at the slope that we had. Now this is, you probably have different, if you remember we had different values for this. I just didn't get this arrow out. Use it. You probably had different equations. I want you to copy down this equation on the top of your line of best fit part 2. So, the equation that we come up when we did this is y equals. So up here I'm going to go y equals a negative 4.375. Wait, that's the wrong one. Just a moment. That was for hours of practice. Wait a minute. There we go. We converted these to decimals, didn't we? So let's go ahead and convert them to decimals. Because we decided decimals was maybe a little easier to deal with than this stuff. So, y equals 0.5x plus, I'm going to have to put my calculator out and divide by 2. Oh, no, I don't. What's 17 divided by 2? 8.5. Okay, so does everybody understand that that's the same equation as y equals 1/2 x plus 17 over 2? Okay. What is the slope or what's the slope in that problem, in that equation? 0.5. So for problem number 2 it says, what is the slope? Well, m equals 0.5. What does it mean in the context of the problem? By definition, what is slope? And it's a change in y over a change in x. Remember that? That was the definition I gave. Well, remember that when you see that, like, that divide sign or that fraction sign, that means the same thing as per. So when we had this in slope form, we said that, oh, that's the same thing as 1 over 2, right? What was our y's? Was it the years or was it the population? Population. So population's on top. And on bottom was what? Years. Okay? So what does it mean? It means it's a change. Now, was that a change up or a change down? So every year we were adding 0.5 to it on our graph, right? Let's scroll down to our graph, scroll back up to our graph. Over here. I told you you're going to have to bounce back and forth a lot. Keep going. See, on our graph on Unit 4, Worksheet 8, notice that for every unit that we go to the right, we go up half a unit. Okay? So that's what's happening with that line of best fit. Going up half a unit, approximately. So, what we have here, where this little thing here is per. So it's the rate. Learn to write. It's the rate of population change per year. Or notice it's my top per my bottom on my slope. Now we've dealt with that actually 3 different times. This is the 3rd time we've dealt with it. So you ought to be able to start looking at that and know what slope is. Slope is always the rate of change. Always the rate of change. And it's always going to be the rate of change of your X or your Y per your X, your population per your year. Did everybody catch that? Well, if you get confused and you don't remember which one it is, think of the slope fraction. What goes on top? Your Y. What's your Y? It's your population. Okay? So if you ever get confused, think about that fraction. Alright, so, I forgot to do something up here. If our years was our independent, what's our dependent? Is the population. Alright, so for number 3 now, using the population problem. What is the y-intercept and what does it mean in the context of the problem? So let's look at our equation. What is our y-intercept? The population. Well, what was the number on it? What was it? 8.5. So it's the population. So B equaled 8.5. So it's the population. Now let's look at our graph. 8.5 is right here, isn't it? How many years passed? Oh, that's 6. How many years passed when we were at 8.5? None. No years passed. What year was that according to our table? Yeah, so it was the population in 1965. That's what our y-intercept means. In the context of the problem. Okay, you ready to use your little clickers now?
Yeah, I'm ready.
Okay. The problem number 4 says use the equation. So we've got the equation up there. In number 1 to predict the population in 2010. If you think I would plug in 2010, press A. If you don't think I'd push in 2010, now just a second, I got to set it up. Press B. Okay, if I'm going to plug in 2010 for my X, press A. If you don't think I will, push B. Let me set it up here real quick, just a second. So, if you think I'm going to put in 2010 for X to calculate the population, push A. If you don't think I will, push B. Now, I'm only going to give you like 30 seconds. Oh yeah, when you do this, you're going to push A or B and then hit send. I'm sorry. Forgot you guys don't know what you're doing.
Oh my God.
So you see how those blue squares come up? That tells me that number's the answer, the dark blue.
Let me change it to green. Do you have to change it?
You can change it.
So clear?
All right, it's done. So we had approximately 9 people think yes, we put in 2010, and 8 people thought that we should put, no, it was a little over, yeah, about 8, thought we should put in, not put in 2010. The correct answer is you do not, it's B. Who thought, can somebody explain to me why we do not put in 2010 into the equation? Right, we were measuring the years from 1965, weren't we, when we did the graph? So, we have to find out how many years passed from 2010 to 1965. How many would that be? Well, let's see, 40 would be 2005, and 5 would be 45. So in this case, x equals 45. That's the number of years that passed from 1965. So I'm going to use my equation to go y equals 0.5 times 45 plus 8.5. Notice that's the same equation I just plugged in 45 for my years. Does everybody understand how I did that? Okay. So, now I want you to calculate it, and then you put in the answer. If you need to do symbol is that SYN, that's where your decimal is. So if you need a decimal, you hit it once and decimal's right there. So you guys see if you can find out how many people there were in 2010. There will be in 2010. So I'm going to give you about 2 minutes. Does that sound fair? So, I'll give you about 2 minutes to calculate. Okay, indeed, yes. The answer was 31. Okay? If you punched in your calculator right, you should have gotten 31 out of that. Yeah, I noticed we got like one that's negative, so you're saying it was like 216 years ago. No, the population was negative 216. Do you have negative population? No, you can't. Okay, guys, just one category. I'll please be quiet right now. Okay, 30, I imagine that probably some of us just do something else, putting it in the calculator. Or we just put it in the thing. So your answer should have been 30. Okay, number 1 at 5 says use the equation in number 1 to predict the year that the population reaches 37.9. Would 37.9 go in for Y or X? Why is that? Yeah, well, remember that the dependent variable is your Y. Our dependent in this was the population. So it has to go in for Y. So we're going to have 37.9 equals 0.5x plus 8.5. I want you rounding to the nearest year. Tell me what year the population reaches 37.9. Okay? When you get your answer, punch it into the thing and then hit send. Okay? Okay, so our variety of responses that we have here are everything from 58.8, which somebody didn't round, which is okay. Okay, on up to 2,059. Which one of those answers do you think is right? Okay, listen. Does everybody understand why 2024 is the right answer? Yeah. Because when you solve, you'll come up with 58.9. You'll see over there on number 5 on the overhead that that's what I have. I rounded that to 59, right? You have to add that to 1965 because it asks for what? It asks for the year. It didn't ask how many years passed. It asks for the year. So you have to read very carefully these problems to know what to do. Is there any questions? No. Okay. Let's go ahead and go to the next page. Oh, you want me to leave that up for a bit? Who had really good notes from yesterday? Oh, wait, I'll scroll down. Okay, I'm going to scroll down, and we're going to look at these notes that I have up here. This was the equation we come up with approximately. We may have a little something different on our notes, but the equation that we're going to use on problems 2 through, for the second set of problems will be y equals the negative 4.375 x plus 55. Okay. Because you weren't here, you're not going to know this. Just write this equation down. Yes. On the back side. Oh, did I send the wrong thing? I'll re-up that. So this is what you should be doing. I just sent the wrong file. Okay. For problem number 1, we're now looking at the hours of practice in the placement problem. I want you to decide which one is the independent and the dependent. We're going to make, if you think this one is the independent, then push A. If you think that one is the independent, push B. Just a second, I got to start it.
We're trying to find independent?
Yeah, which one's the independent?
Number 4 got it wrong.
Okay, everybody but one person identified it. Remember, if you've got a vertical chart, your X is always on top, your Y is always on bottom. X is always independent, Y is always dependent. So, your correct response was independent is hours of practice. Your dependent is the placement. Go ahead and mark that down. Does that help? Hours of practice. Does that help? Hours of practice is your independent dependent placement. So now, remember that I said that we were going to use the equation y equals negative 4.375x plus 55? Yeah. I want you guys to do problem number 2. We're not going to use the clickers on this one. It's not a real good one to do it. Okay, so see what you can do with problem number 2. Yeah. Okay, so your slope was a negative 4.375. Yes.
Okay, so number 2, my slope is -5.
Okay, remember though I told you we were using that same equation, always using the same equation. Even though we had different equations, right Jacob? We were all using that equation, right? Okay. So, we went ahead and found the slope of that. The slope should be the rate of decrease in the placement per hour practice. Notice my hour practice is X. It's what comes, it's the per whatever your X is. Any questions about how I got slope? Alright, you guys do the y-intercept and interpret it. Okay, so on number 3, guys, please be quiet. On number 3, you should come up with B equals 55. And that's the placement with no practice. Makes sense from the graph. If you look at the graph, the y-intercept is like way up here where we can't see it, isn't it? Well, how many hours of practice did we have when we crossed this line here? None. Didn't we? Any questions about the y-intercept? Okay, I want you guys to do number 4 and 5 on your own. Okay, I'm going to put the answer to 4 up here. You click it in with your clicker. And then I'll ask for 5 and you click it in with your clicker. So see if you can do number 4 and number 5 on your own. Okay. You should have finished up calculating. We're going to get it now. So,
I didn't know how to do it. Yeah.
talk about it. Okay, number 1, where we plug the 1, or number 4, where we plug the 1 in. So we plugged it in, and number 4 we plugged it in. Okay. Once I start talking, guys, you gotta stop, or that won't pick me up at all. Okay? What we did in number 4 was we plugged 1 in for X, and then we calculated it out 50.625. In number 5, 1 went in for Y because of its placement. Okay? And what you would do is that you would have to solve for X to find out how many hours. You do that by subtracting 55 first, and then dividing by negative 4.375. I come up with 4.343 hours. Let's see how you guys did. Yeah, I don't see any of us that did it. So do we understand what we did wrong?
I didn't put the whole number down.
We'll put 1, 2, 0, 0, 0.
Oh, yeah, I would accept this one here, but there were only 2 responses like that. We had one at 12.34. I'm not sure how. Oh, yeah, that would have worked too. Those two are good. I don't know. Somebody put a smiley face in there. Oh. And then we got a 1,000,000 and 25.6. I'm not sure where this one comes from. I can assume what's going on with these things. Okay, questions? Okay, here's little 1. We're going to do Unit 4 Worksheet 9 now.